Okay, let's talk about graphing sine functions. So first let's set up some values here, some x and y values. So sine of x here is equal to our y value. So let's say that we start at x equals 0. Well, sine of x is 0. The next angle is what? Let's go 30 degrees, which is pi over 6 radians, 1/2 pi over 4. This is 45 degrees. This was square root of 2 over 2. Pi over 6 is, or pi over 3 is 60 degrees. There are only 360 degrees in one half of rotation, 180 degrees. So pi over 3. Remember, they're pi radians in 180 degree rotations. That's other ways to remember this. And then pi over 2 is a halfway point. Sine of that is 1. Okay, pi over 3, this was what? Square root of 3 over 2. This is 90 degrees. Let's continue this on till we get back to the same value again. So 2 pi over 3 we've got this is square root of 3 over 2, 3 pi over 4. This is 135 degrees. 2 pi's over 3 is 120 degrees. 3 pi over 4 is square root of 2 over 2. So here I've done all these. I'm back to 0 again. So essentially what I did was, if this is our unit circle, I started here and I took my angles this way and I went all the way around to here. So notice when I did that, the y values were always above the x line here of 0, so the y values were always positive. Now, one thing that might be a tad confusing here is the x here is not the x value that I'm using here. The x here is just a variable in this function sine of x. Because what I want to do is I want to plot this argument, or the independent variable versus the dependent variable y. And that's what I want to do over here. And let's do it here like this. So now I want to plot this function that I have in the table over there. Values of y equals the sine of x, or f of x. So here we have y, and here we have x. So the range of this in the table over here on the left goes from 0 to 1, and then back down again to 0. So let's put 1 here. I'll just put 2 up here for reference on the y scale. And our x values are in terms of pi, or fractions of pi. So let's put pi here. So we know that's like 3. we can estimate that like 3.14. So that's like a value of x of 3.14. That's pi. Now I want to plot these things. So, for example, let's cherry pick some of these values. At 0, when x is 0, y is 0. When x is pi over 2, or halfway between these, pi over 2, y is up here at 1. And then halfway between those is the 45 degree, which is pi over 4. This is 2 pi over 4, so this will be 3 pi over 4. And when x is pi over 4, y equals square root of 2 over 2. The square root of 2 over 2 is approximately 0.707. 0.707. So when we are here, if this is the halfway point, if this is 0.5, 0.75 would be here, so we're a little below that. So this is here, and this is the same value. You see, this is here. Also, when we hit pi, we get back to 0 again. And I could stick in these pi over 3 and pi over 6's at the 1/2 point. They're kind of difficult to squeeze in. I guess this is here, and then this is here. But what you see here is a nice rounded, what we call a sine curve, that goes up and comes back down. And that's going halfway around a circle, the unit circle. So that's half of our function. Now as we continue on, the y values will go negative, and eventually they come back to meet up again with the x-axis at 2 pi. And as we continue on in the x-axis now, and we get to 5 pi over 4, that's 0.707, or square root of 2 over 2 again, but it's a negative now. So that's somewhere around here. And then 3 pi over 2, we actually hit -1. We come back down here, halfway between these two, at 7 pi over 4. It's here. So I'm not drawing all the points in here. Take a little bit of time, but you can do that. And then we come back at 2 pi, we hit 0 again. And that's what the sine function looks like. Now, if you were to head in this direction, distance of minus pi, then minus pi over 2, this would continue on. Actually, I should draw this all as one color. So I've changed this all to one color, so the red is just the sine function over here, but as I go in the negative direction, this thing continues, and it'll go on for infinity. And if I were to go in the positive direction, the same thing would happen. This would continue on and go for infinity as we got larger than 2 pi over here. So this is 2 pi. So out to 4 pi, this would have started repeating again. So this function just repeats over and over. They call this a sinusoidal function. Well, the red portion, where this first starts, and when you start at 0, here on the unit circle, and remember, if we go around the unit circle 1 full revolution, that's what this red represents, 1 full revolution. We call this the period. The distance here that this wave has moved is our period. And the period of this function sine of x here equals 2 pi, that's the distance. And the height that this function gets above the initial reference of 0, we call this the amplitude. The amplitude. And I adjusted it. Okay, so we have a period or a function and our amplitude. Well, the cosine function behaves the same way. Here I've copied the table, similar table that I just did up here for the sine function, for a cosine function. The difference is the sine function starts when x equals 0, y equals 0, the value of function equals 0, and then it moves up to 1 and then down. The cosine function is different. When x equals 0, the cosine value is 1, and that's because at the unit circle we're talking about this point out here. And we know the cosine of the angle equals the value of x in the unit circle. Now, that's not the same x's that we're drawing here on the line. The x, so don't get confused about that. The x that I'm drawing here on the line, this is like what we would normally call alpha or t, but I've just described this as the argument x. So when I put in these values, different values of different angles for the cosine function, you'll see the cosine function starts at 1. It passes at pi over 2, 0, and then it comes back to minus 1 when we get to pi, the halfway point. So you can see that represented up here in numbers. And then as you continue on out to 2 pi, or the full rotation around the unit circle, this gets back up to 1 again. So this would also continue on for infinity and just keep going like this. As you got larger in pi, it would just keep going at the same size. And again here, with this, also in the negative direction it goes. Again, in here, you can see that our period P equals 2 pi, and our amplitude equals 1. Notice, the amplitude is half of the range of this function. The range goes from minus 1 to 1, the absolute value of the range, that is. So this has an absolute value magnitude of 2 in the range here from minus 1 to 1. So the amplitude is half of that, 1. Okay, now the next thing we want to talk about is we want to talk about the most general form, or one of the most general ways of representing these functions in this form. And all these coefficients and constants here represent different types of behavior. And as you progress through your scientific career, if you get into electricity and you're working with alternating current, you'll have to deal with the phase angle, and the amplitude is important. But I'm going to talk about this in the next